Okay, so this is a linear acceleration question where there's really two parts to it. We've got x and we've got y. 2 points. What they do is one is travelling towards the other, one is going like that, and the other one's going like this. So this is x and this is y. Now what you're going to do is use these equations for x and y. The piece of information that they give you in this question is that they start 400 meters apart, and what we want is the time which elapses before they meet. Now the real thing for this you have to notice, so you want to think about what's special about that. Well, when they meet, the distance that x covers plus the distance that y covers is equal to 400. And that's the crucial part of this question. So if I do for x first off, now I know that the initial velocity is 3 meters per second. Comes there. I know that the acceleration is 4 meters per second squared. I'm looking for the time, and I have an expression for displacement which is sx. In blue I'll do the y out very similarly. The initial velocity for y is 7 meters per second. Acceleration is 2 meters per second squared. Need an expression for time, and I know that the s is equal to sy. So the equation I'm going to use, first off, look back up to these three, 1, 2 and 3. Now you'll notice if you look at what we have and what we're looking for, that number 3 is the best one to work from here. So we have, I'll write it in black in the middle between the s is equal to ut plus 1/2 at squared. So for body x, we have sx is equal to ut, which is 3t plus 1/2 at squared. A in this case is 4 meters per second squared. So put that in there. We get an expression for the distance that x travels is 3t plus 2t squared. For y, very similar. Sy is equal to 7t plus 1/2 2t squared. Sy is equal to 7t plus t squared. The crucial thing for this question is you have to spot it at the start as s, the distance x covers, plus the distance y covers is equal to 400 meters. So I can fill in these. 3t plus 2t squared, that's the distance x covers, plus 7t plus t squared, the distance that y covers, is equal to 400 meters. Now that we have it like this, we can add the t's, we can add the t squareds. So we'll do that. We get 3t squared plus 10t, and then bring this over, be minus 400 is equal to 0. Now, a couple of ways to do this. It's a quadratic equation. You could use minus b plus or minus the square root of b squared minus 4ac. You could look for factors that will work either. In an exam situation, I'd probably always be thinking using the minus b plus or minus the square root of b squared minus 4ac all over 2a. The reason why I do this, with big numbers like this, it could be awkward enough finding your solution, especially when there's a number by the t squared. So I'll fill it into this. I'll do it this way. So I know that b here is 10. I know that a here is 3 and c is minus 400. So I'll just quickly write these in. Minus b, minus 10 plus or minus the square root of b squared, which is 100, minus 4ac, 4 times a, which is 3, times minus 400 there, all divided by 2a, which is 3. Be very careful for the signs of this, so we'll fill these in. Minus 10 plus or minus the square root of 100. Minus 4 by minus 3 is minus 12. Minus 12 by minus 400 is 0, 0. It's going to be a plus anyway. 4,800 all over 6. Is that correct? Yep. So what we have here now is this is equal to minus 10 plus or minus the square root of 4,900 all over 6. And you might realise that 4,900 is very like 7 squared is 49. In fact, 70 squared is 4,900. So we get an answer of minus 10 plus or minus the square root, or not the square root of that now, plus or minus 70 over 6. The minus value won't make any sense, could be left with a negative time, so we know that our time is going to be the plus value of that, minus 10 plus 70 divided by 6, which is equal to 60 over 6, which is 10 seconds. The minus value, which would be minus 10 minus 70 over 6, be equal to minus 80 over 6. It doesn't make any sense, so we can leave it out. So now that we have the time is equal to 10 seconds, the distance which each of them travels in that time, well, we've got these two equations. I might just fill them in red here. I know that time is 10 seconds, so we want to know the distance it travels in 10 seconds, so just fill in that for the time. 3 times 10 plus 2 times 10 squared, which is equal to 3 tenths, so x is going to travel 30 plus 200. So that's equal to 230 metres. SY then must travel 170 metres because they have to add up to that distance. Just to prove it, we'll throw in 10 into this solution, to this question here. I'll again do it in red just so that we can see it. So SY will be equal to 7 times 10 plus 10 squared, which is equal to 70 plus 100, which is 170. And notice that this plus this is equal to the 400.